Dear student, Assalamu alaikum. I hope all of you doing well. In econometrics, today we are going to explore serial correlation. That is one of the important assumptions of the OLS model. Learning outcomes. After watching this video, you will be able to understand serial correlation, versus autocorrelation, types of autocorrelation, consequences of autocorrelation, testing for autocorrelation, and in the last, how to reduce the autocorrelation. So let's start from the definition. What is serial correlation or autocorrelation? Serial correlation is the relationship between a variable and the lagged version of itself over various time intervals. Repeating patterns often show serial correlation when the level of a variable affects its future level. In finance, this correlation is used by the technical analyst to determine how well the past price of a security predicts the future price. Types of autocorrelation. Now we briefly discuss the different types of the autocorrelation or serial correlation. Most common form of the autocorrelation or serial correlation is first order serial correlation, which can either be positive or negative. So positive serial correlation is where a positive error in one period carries over into a positive error for the following period. Negative serial correlation is where a negative error in one period carries over into a negative error for the following period. The second type is the second order serial correlation, is where an error affects data 2 times period later. This can be happen when your data has seasonality. Orders higher than the second order do happen, but they are rare. So next question is how to detect the autocorrelation. Here are some common tests for detecting the autocorrelation. You can test for the autocorrelation with a plot of the residual, plot ET against T. Look for the clusters of successive residual on one side of the zero line. You can also try adding a lowest line as in the image below. Second is the Durbin test. Third is the LM test, and fourth is the correlograms. And the last one is the modern eye statistics. Out of these tests which have been explained previous slides, the most common used test is the Durbin statistics. Now we'll briefly discuss what is the Durbin statistics and how it detects the autocorrelation or the serial correlation. The Durbin statistics DW is a test for the autocorrelation in the residual from a statistical regression analysis. The Durbin statistics will always have a value between 0 and 4. A value of 2 means that there is no autocorrelation detected in the sample. Values from 0 to less than 2 indicate a positive autocorrelation, and the values from 2 to 4 indicate the negative autocorrelation. So look at the formula for the Durbin-Watson statistics. D is a sum of ET is the error term of the current time period minus ET minus 1 stand for the error term of the second time period, past previous time periods whole square divided by the sum of current error term whole square. Now we discuss the consequences of the autocorrelation. When the disturbance term exhibits the serial correlation, the values as well as the standard error of the parameter estimates are affected. In particular, when the residual are serially correlated, the parameter estimates of the OLS are statistically unbiased. With autocorrelated values of the disturbance term, the OLS variance of the parameter estimates are likely to be larger than those of the other econometrics method. The variance of the random term mu may be serially underestimated if the mu's are autocorrelated. Finally, if the values of the mu are autocorrelated, the prediction based on the ordinary least squares OLS estimates will be inefficient. So how can autocorrelation be reduced? There are basically two methods to reduce the autocorrelation, of which the first one is most important. Improve model fit. Try to capture the structure in the data in the models. Improve your model. If no more predictors can be added, include AR1 model. Thank you for your patience.